A pleasant day to each and everyone. Welcome to Miss Precious Math Class, where mathematics topics are taught simple and easy. Hi, this is Miss Precious, your mathematics teacher. For today's lesson, we are going to focus on the topic Subset and Universal Set, Part 1. Consider the picture below. Can you describe the picture given? Very good. There are different colored fruits given, and they are all inside the circle. Based on the picture, how many sets do we have? And describe each set. That's right. There are 3 sets on the picture. The first one is the set of all fruits inside the biggest circle, followed by the set of red fruits inside another circle, and last is the yellow fruits inside another circle. The set of fruits inside the biggest circle is called the universal set, while the 2 circles inside the biggest circle are called subsets. Let's start with subset. To understand subset, consider the following sets. Set A is equal to 2, 4, 6, and set B is equal to 1, 2, 3, 4, 5, 6, and 7. What did you notice on the following elements of set A, starting with 2? Great observation. 2 is an element of set A given by the symbol 2 is an element of A, and 2 is also found in set B given by the symbol 2 is an element of set B. How about 4? Good job! 4 is an element of A, and also 4 is an element of B. Let's try 6. Great thinking! 6 is an element of A, and 6 is also an element of B. Therefore, all of the elements of set A can be found on set B. Thus, we can define subset as every element of set A is contained in another set B. Therefore, A is a subset of B. Set A is a subset of set B if and only if every element in A is also an element of B. So there are 2 kinds of subset. The first one is A is a proper subset of B, and A is an improper subset of B. So let's find out what's the difference between the 2. Let's start with proper subset. Set A is a proper subset of set B if A is a subset of B, but A and B are not equal. 2 sets are equal if they have exactly the same elements. This simply means that all the elements of set A are contained in set B, but the elements of set B are not contained in A. Their elements are not exactly the same. Proper subset is denoted by A, proper subset B, or simply A is a subset of B. So let's have some example. Set A is equal to 2, 4, 6, and set B is equal to 1, 2, 3, 4, 5, 6, 7. Let's check if A is a proper subset of B. Identify if the elements in A is also an element in B. Let's try to mark all the elements that has a match. Let's start with 2. 2 is an element in set A. Does it have a match in set B? Good job. So let's mark it this way. How about 4? Great thinking. And 6? Good job. All elements of set A is an element of set B, we can conclude that A is a proper subset of B. How about this next example? A is equal to 1, 3, 5, 7, and B is equal to 3, 1, 7, 5, 9, 11. Identify if the elements in A is also an element of B. Or does A is a proper subset of B. So let's mark the given elements if it has a match on the other set. Starting in 1. Does the 1 in set A has a match in set B? Good job. How about 3? Nice. And 5? Excellent. And 7? Good job. You will notice that all of the elements of set A are all marked, but the elements of set B are not. Since the element of set A is contained in set B, but the elements of set B is not contained in set A, we can conclude that A is a proper subset of B. Now let's proceed with the improper subset. Set A is an improper subset of set B if and only if A is a subset of B and B is a subset of A. In other words, the two sets have exactly the same elements. This means that all the elements of set A are contained in set B. Likewise, the elements of set B are all contained in set A. Improper subset is denoted by A is an improper subset of B. The line below the subset symbol indicate that A is equal to B. Two sets are said to be equal if they have exactly the same elements. Let's have some example of improper subset. Given that A is equal to 1, 3, 5, 7 and B is equal to 3, 1, 7, 5. Mark each element of set A that has a match in set B. Let's start with 1. Does 1 has a match in set A and set B? Yes. How about 3? Nice. How about 5? That's right. And 7? Great thinking. What did you notice on the marks of the two sets? Right. All of the elements in set A match all of the elements in set B. Since elements of both sets are the same, thus A is a subset of B and B is a subset of A. We can say that A is an improper subset of B. Another example, V is equal to the vowels of the alphabet and W is equal to A, E, I, O, U. What are the elements of set V? Good job, they are A, E, I, O, U, which is exactly the same with set W. Since elements of both sets are the same, thus V is a subset of W and W is a subset of V. In symbols, we can write it as V is an improper subset of W. To check if we understand the lesson, let's have some activity. Tell whether each statement is true or false. Let's start with number 1. The set containing A, B, C, D, a proper subset of the set containing A, B, C, D. Is it true or false? Excellent. The answer is false because two sets have exactly the same elements. Therefore, the two sets should be improper subsets. Number 2. The set containing 10 and 20 is a proper subset of the set containing 1, 2, 3, 4, and so on. Is it true or false? Very good. The answer is true because the set containing 10 and 20 are also an element of the given set containing 1, 2, 3, 4, and so on. There are still elements following 4, and this goes on to positive infinity. How about number 3? The set containing 4, 3, 5 is an improper subset of the set containing 5, 3, 1. Is this true or false? If your answer is false, good job. Because even though they have the same number of elements, but their elements are not exactly the same, thus the two sets are not subsets. And you will notice that 4 in this set is not contained in the other set. The set containing 4, 3, 5 is not a subset of the set containing 5, 3, 1. Number 4. How about the set containing X is a proper subset of the set containing A, B, C up to Z? Is this true or false? That's right. The answer is true. Because X is an element of the set of English alphabet. So, all of the letters in the other set here, A, B, C up to Z, are the letters or the elements of the English alphabet. And number 5, the set containing capital letter A is a proper subset of the set containing lowercase letter A, B, C. Is this true or false? If your answer is false, good job. The element capital letter A is different from the lowercase letter a here, and these two are not the same. Therefore, the given set containing A is not a subset of the set containing A, B, C. That is all for our lesson for today. We're going to continue this to the next video titled Subset and Universal Set Part 2. Thank you very much. See you on our next lesson. Stay safe and God bless.